My guest today is Bill Wiseman. He leads McKinsey's global semiconductor practice and founded their Taipei Design Lab. For that, he designed integrated circuits at IBM and was a U.S. Navy SEAL where he led SEAL Team 5. Today, we're going to be talking about the semiconductor industry from a national security standpoint. So welcome, Bill.
Thanks, Chase. Great to be here.
So I guess to lead off, if China blockades, invades Taiwan in some manner, I think it's very likely that the United States and at least some of our allies get involved. There's a direct military conflict with China, and Taiwanese fabs are out of commission long term. If that happens, obviously, since Taiwan produces more than 90% of the leading edge chips, AI industry grinds to a halt. The ripples to the broader tech industry, broader global economy from there. We're looking at many trillions of dollars lost, global recession at a minimum, ignoring any effects of war. And so where do you see that risk actually priced in? Is it CapEx hurdles? Is it equities, dual sourcing, stockpiling somewhere else?
So that is the question that I think everybody's wrestling with, and it has been wrestling with for years. So the first thing I'll say is, what are the implications of that kind of an event? Mm-hmm. And I just want to focus on one implication, which is Taiwan can't ship silicon.
Right.
So if that is the case, regardless of the rationale of why that is, whether you said a couple, could be a ginormous earthquake, it could be there's a number of reasons why why Taiwan couldn't ship silicon. But that I'll reflect on on that, and I would say the real implication of that is a broad spectrum failure of the electronics supply chain, broadly speaking. Now you mentioned one reason why it wouldn't work. Well, Taiwan ships about 90+% of leading edge silicon that is instrumental to high performance compute, which is what's been really driving the global economy of late. But there's a lot more concentration in Taiwan than just leading edge silicon.
Right.
Nobody knows that Taiwan produces 65% of all NOR flash bits. Mm-hmm. You can't ship a car without NOR flash bits. That's where all the code for the engine control unit's stored. There's a lot of other points of concentration. There's a lot of memory that's in Taiwan, a lot of DRAM. Almost all of the world's advanced packaging capacity is in Taiwan right now. So it's more than just leading edge logic that is going to be suffering. So there's a lot to worry about there. Taiwan's also the biggest hub for electronic manufacturing services and original design manufacturers that actually are making the server boards that go into the data centers. And yes, there is leading edge logic on those, but there's a lot more than just that. So, and I will step back from that before I talk about where is risk priced in. But this is a 15-ish year problem to solve. This is not something you're going to solve in an administration, right? A U.S. administration can't solve that problem. Multiple U.S. administrations need to look and solve that problem. And you do see some steps in the right direction. I mean, TSMC has made some real commitments to build at their campus in Arizona. And just a couple days ago, they committed to even going further on moving some of that capacity to the U.S. And so that's going to fix the problem. But again, the time constant in this industry is much longer than people know. It takes a good 4 or 5 years to build and ramp a fab. And when TSMC wants to build 6 or even 12 in a cluster, that's decade. That's a decadal or double decadal problem. Okay, so to your question, where is risk priced in? I'm not going to comment completely on valuations. But I don't think it is priced in. I look at, if you look at the history of just what is the top market cap company in the world, for a long time we were stuck at around, some company would bump up against about $500 billion, maybe a little bit more than that. And now you've got,
well, even pre-AI, it was basically at $1 trillion.
Yeah.
Right? A couple years ago.
And so now you've seen this explosion in market cap for companies that are anybody that's involved in AI. Is getting a huge valuation premium.
Right.
And when I step back and think about this and the second order effects of why aren't investors pricing this in, I come to two conclusions. Either number one, they're not priced in,
right,
because Taiwan not being able to ship silicon would hurt every economy, not just the U.S. or the Western world. It would hurt every economy, and that's because leading edge silicon is important to manufacturing industries, important to servicing industries. And so if Taiwan can't ship silicon, every economy in the world is going to suffer. And the more degree your economy is skewed towards manufacturing, the worse off it's going to be. And so if you think, China is the manufacturing center of the world, which they are, it's going to hurt China pretty bad if Taiwan can't ship silicon. So that, I mean, it's a little bit of a corner case there. But if everybody suffers, you have to look at the game theory of it, and you say, like, this is like brinkmanship.
And so the thinking is not that deterrence will hold; it's that there's no possible way to hedge against it. So it's priced in universally, effectively.
That's
or
right.
Not, right?
And honestly, we looked at it. There's industry associations for different industry, electronic manufacturing industry associations, semiconductor industry association, that kind of industry associations. And when you get a collection of executives together to talk about this, almost none of them want to take any action on this because it would be really expensive for one player to take action. But if the entire industry doesn't take collective action, you still can't ship a computer or a server because you're going to miss one part or whatever it happens to be. And so it's a little bit of you have to get into the game theory of this. And at the end of the day, it's kind of a prisoner's dilemma, and nobody really wants to act.
Right. So you need a coordinated body, possibly that's the government, right?
So that was one side of why I think it may not be priced in. But then if you argue and say no, all investors are rational or markets are rational, that means that risk is priced in universally. And so if that's the case, then there must be an offsetting on the positive to that. And the offsetting on the positive is just kind of what we saw a couple days ago in mid-January, where there's a tremendous amount of talk of, is there an AI bubble?
Yeah.
And then the bellwether of the industry, TSMC, comes across with a blowout quarter and great forecast. And that kind of lifted all boats, saying, TSMC's lead times to make a chip are about 6 months, 180-day lead time to make something. They have pretty good forecast on what's going on in the next year, and they're being pretty rosy. So to me, that means there's upside ahead, and that's the signal that everybody's clear on.
So Xi Jinping comes out tomorrow. He says, Taiwan, separate country. God bless. What happens to NVIDIA, TSMC? All the dependencies, like stock market go up 1%, 5%. No one cares.
I think everybody cares, from
a market's perspective.
Maybe before I comment on what I think the bump would be, and which is anybody's. By the way, if I knew that answer, I wouldn't be working at McKinsey. But I will say that I think we really focused a lot on Taiwan, and the electronics manufacturing writ large has grown for 35 years on the basis that global commerce functions. Right. And if global commerce stops to function or ceases to function, that's a big problem. Yeah. But a step in the right direction would be exactly what you just said. If all of a sudden we see signals that the economic leaders of the world say we're leaning into global commerce again as opposed to a multipolar world, which seems to be the way we're going. Right. I think that's a boost to all valuations. Okay. Right? Yeah. It takes risk. It takes some risk off the table.
Well, so go back to what you said about it's a 15-year project. My internal estimation was that actually it was more than 15-year projects. So that's heartening. And TSMC, obviously, they're being strong-armed to invest in the United States and Arizona and whatnot. But how actively, if at all, is the Taiwanese government pushing against this? Right? They're not stupid. They know that the entire world is rooting for them, in part because they don't want the global economy to crash, due to some China-related event that knocks them out. And so, are they pushing back against this to the extent possible? Or what are they doing, and how are they thinking about this?
So, first off, Taiwan is a bipartisan democracy by and large, just like the U.S. is, and I would say the populace of Taiwan is almost as polarized as the United States population is, and every election is close. And so trying to speak on behalf of Taiwan is impossible to do. Okay. But I will say the way the press and the way that I would say politicians talk about the semiconductor industry is the silicon shield, right? That kind of sits over Taiwan and makes them nearly unassailable because no, as I said before, nobody wants the doomsday event of Taiwan not being able to ship electronics or leading edge ladder products.
Does the KMT, which is like the opposition, generally pro-China party, do they also buy into that silicon shield mentality, or are they think about it differently?
I think every politician thinks about it differently, and they change their minds very frequently. When I lived in Taiwan, I used to call Taiwan a teenage democracy because you still occasionally Congress would look like the Jerry Springer show, and you'd have people hurling chairs at each other in the legislative branch. They're a little bit more mature now, and I think everybody acknowledges kind of the physics of the industry. Yeah. That Taiwan is in a almost unassailable leadership role from a perspective of being able to supply a lot of products into the semiconductor and electronic supply chain. But I would say that generally speaking, the KMT, which is one party, they're much more pro trade. They're much more pro integration with China, and I don't want to say that doesn't mean that they're an independent country or anything like that. That's the wrong attitude to have. But the DPP, which is the alternative party, is much more bent towards
independence.
We're more westward leaning, and you got to be really careful when you use language around talking about China U.S. or Taiwan U.S. and Taiwan China rhetoric and policy. But I think everybody kind of acknowledges the physics of the relationship between Taiwan and the rest of the world, and they're going to use that for whatever political purpose they have on any particular day.
Okay, and so we've talked about there's various things there's that China could do, and they get varying degrees of coercive, right? They could blockade, they straight up invasion, and then if it's a blockade, there's lots of subtle layers to a blockade, and this is a very political question depending on who's in power and what the politics are around the world. But if there is a soft action against Taiwan, how willing do you think that the U.S., the EU, Japan, et cetera, to sanction China and not let those chips flow, even if from a physical perspective they still can? Is anyone willing to incur that pain realistically?
I'm going to speak on behalf of corporations, not governments. Okay. And I would say that 10 years, I probably knew what governments were going to do. Mm-hmm. Today, I can't even predict that. I get surprised more often than I don't with how governments are reacting to various events that happen around the world. I will say that if I was on the board of directors of a publicly traded company that was dependent on electronics for some way, shape, or form, which is pretty much every company in the world,
everyone, right?
I would say I need to have a plan for that to happen. I need a plan for it. If Taiwan can't ship, what happens? And everybody's got about 3 months of inventory on hand, maybe 70 days. Yeah. That's not a long time. And you need your management team to be able to take action. Be ready for that event to happen, and have a plan that you're going to be able to react to. And that plan, maybe we're not going to do anything because the world's going to solve that problem for us, and we're all equally going to get punished if indeed that happens. There may be some other subtleties, like you said, a blockade. Okay, well, look what just happened in Venezuela. Maybe that gives some inspiration, and it's some kind of a
decapitation
event or something like that. We'll be ready for that too.
Right.
What would that mean, and how would we play that out? And I think if you look at some of the wargaming that's gone on in the past year in the Western world about what would a Taiwan-China conflict. I mean, Lyle Goldstein just put out some really high-quality content on where he thinks things would go, and he's a bit of a luminary. He's a China luminary and really has some interesting thoughts there. That would be a terrible conflict. Yeah. And I don't think anybody wants to see that happen.
But I'm not rooting for that.
If you're on the board of directors of a company, you kind of got to be ready for that to happen. And I talked to a lot of boards of directors. I don't hear anybody talk about that. So I think it's important to be able to quickly react in these circumstances, and the speed of response and the speed your management team is able to operate with, I think, is going to define a fair bit of value that you can not lose in the circumstance.
Okay, so if you're advising sovereign wealth fund, a extremely large Fortune 50 company, what they need to be looking for, right? Put your global risk hat on. Hopefully they're engaging these teams, but it sounds like they might not be. What are the 3, 4, 5 things that they should be looking at, call it quarterly, to evaluate, okay, maybe we really need to kick this hedging mode into hyperdrive here. Because they don't have access to intelligence community documentation, right? And so they're going off of public information. What should they look at?
So, well, I would say I want I want my management team coming up with, I'm just going to broadly say, 3 kinds of responses. I need something that's going to allow me to operate in the short term.
Yep.
Let's call that, within 12 months. I need a way to continue to operate past that domain, and I need to operate between kind of years 1 and 3, and then I need to be able to operate 3 to 5 years out from something like that happening. And maybe maybe the issues get resolved in those timeframes, or maybe they don't. But some of the long-term things, like I need to dual source my next GPU or my next leading edge piece of logic, and I need to be able to target that at a TSMC process, and I need to target it at another process.
And I need to invest in the supply chain teams to know what goes into 3, 4, 5, 6 layers down. Where if that's still dependent on China or Taiwan, I mean, okay, great, might be made in Arizona, but
that's exactly right. And you got to flow that down through the exact 6 layers deep in the supply chain and make sure that you're resilient in that duration. And that's going to be expensive to pull the trigger on that. Because we're talking about a lot of supplier quality engineering work. We're talking about a lot of supplier identification that's going to need to go on. And the CHIPS Act was great. And now we have the TSMC Arizona campus and a bunch of other places in the U.S. where you're seeing semiconductor manufacturing. But the supply chain hasn't moved behind that.
Right.
We're still getting sulfuric acid from Korea most of the time. So it's a
generational project.
It is. And that's why I said it's a 15-year problem, right? We got to really move to solve that. But that's the long term. If we jump to the other end, the short term, most CFOs don't like to hear this, but like you got to kind of build some strategic inventory.
Yeah.
The U.S. has the Strategic Petroleum Reserve. If you're a company that's making electronic components, or you're making electronic systems, or even things that electronic systems go in, you probably want to be thinking about holding some more inventory than you did before. And again, that's expensive. It takes you're deploying scarce capital. You won't be able to buy back as many shares as you may have wanted to, but holding a little bit of strategic reserve of inventory is probably a good thing, and make sure you know how to manage that.
And companies sort of learned that during COVID, right? That just in time, might not be optimal in all scenarios. Obviously, if a CFO, major corporation, got on Bloomberg, profits are down this quarter. We're building up over the next 5 years a strategic, chip supply chain reserve, for Walmart, pick company. Is Wall Street just going to say less profits? How are they going to think about that? Right? Are they just going to be like, you're less profitable, next?
So I judging the valuation implications of that and the investor response to that, I would say it is in the short term difficult to judge, but in the medium term, I think easy to judge. Is that taking risk off the table should be greeted with cheers from Wall Street, and as long as you're doing that in a deliberate way and you're explaining it to the investor base, and you're giving them hey, this is the strategy that we have. We long term are going to pivot our supply towards a U.S. source or whatever it's going to be. But in the short term, we can't make that happen, and we've got to build some inventory in order to, or take some other actions in order to do it. I think you'd hear some investors cheering behind that.
So why don't people do it? Like, is it, are people not thinking about it, but presumably these are smart people? Is it that there are not actually enough people that understand the supply chain inside the United States to execute it, even if, all these companies wanted to, or what's the constraint then?
I think the constraint is a little bit of chaos.
Okay.
I think before we all went a little tariff crazy in April of 2025, you were starting to see companies, in particular the automotive sector, that were all taking steps in this direction.
Yeah.
You had companies looking at components that had a single source of supply, and they in 3 years we're going to have dual source of supply for some of these, engine control parts or whatever that they were really dependent on a single supplier for. And this isn't just a Taiwan thing. I mean, if you look back at, for example, the Fukushima disaster in 2011 in Japan. There were a bunch of fluoridated O-rings that came from a single factory in Kyushu. That factory couldn't ship. And like you fluoridated O-rings, how hard are those to make? Well, when there's only one qualified supplier for the automotive industry, that's a problem. So I think the automotive industry has been through this a lot more than most. And so you did see these companies making movement to be able to build resiliency into their supply chain one way or another. And then all of a sudden everybody got hit with tariffs that shifted very, very frequently,
and keep shifting.
But companies really had to react to that because I mean that's affecting. That's not a resilience question of maybe something happens and I need to be competitive. This is, hey, my profits are going to be down $1 billion or up $1 billion next year. I got to move on that quickly. So that drew the managerial attention of the supply chain teams at most of your discrete manufacturers, be it automotive or guys that make gas chromatographs or whatever it happens to be. Right. They're all looking at tariff implications and how do I tariff engineer my way out of this, or whatever the whatever.
How do I get my exception? Yeah.
Exactly.
Okay, so shifting gears a little bit, right? Talk about anti-China export controls. The U.S. is very clearly interested in anti-China, in stopping China from getting a leading-edge semiconductor manufacturing competency, right? And I think that is like one of the relatively small number of areas that A, China really cares about, and B, we actually, collectively the West, I'd say, have the lead. But that's dependent on a bunch of countries. The United States, Japan, South Korea, the Netherlands, Taiwan, obviously, a handful of others as well. But there's a lot of volatility in U.S. policy right now, and it takes like a collective action to enforce that effectively. And so what is the minimum viable coalition that still matters? And, are we seeing a fracture? Can that coalition like outside of the broader security alliance, or is that dependent on the U.S. being that centralizing, secondary sanctions, obviously, but but can it exist outside the broader security alliance?
It's a great question because it's an extremely strategic question, and it's something that I think many folks are wrestling with. How to think about the competitiveness of that coalition in even the medium term. And the moments just a little history lesson. The semiconductor industry, started in like 1957 when Shockley invented the transistor, and it's grown from there. And honestly, this industry has grown largely commercially, so it's been a commercially driven industry, not a regulatory driven industry, but it's had a lot of regulatory and military interventions as it grew, and most of those interventions were all growth related and support related. So we are now in a regime of restriction, and that never happened before. It really there was a little bit that happened in the 80s when there was some IP theft going on between Japan and the U.S. and other places.
A couple others, yeah.
But I would say the support that governments gave their industries, be it South Korea, be it Taiwan, be it Japan, or the U.S., or even China, it's all support, giving money or potentially manipulating exchange rates to make your products more exportable, that kind of thing. But it's all been support, trying to make the industry more competitive in a certain geography. We're now in a restrictive regime, and that's dangerous. And it's dangerous because there's a political intent behind these policies, but there's a tremendous number of second and third order implications. The clearest of which is that we're in an escalation ladder now. Yeah. And the more you get in an escalation ladder with an adversary that controls the vast majority of rare earth refining capability in the world.
And a lot more.
And a lot more than that. And 70% of steel refining and everything else that China's built over the last 30 years. Wow. That's pretty scary.
Yeah.
And so I think the vast majority of semiconductor and electronics executives around the world are all for support. They're all for, let's make this industry grow and make it more competitive. Because at the end of the day, Moore's Law has been governing this industry for years and years and years. And that's all about making chips better, faster, and cheaper. And as long as we do that, consumers get the surplus and it's all good. When we start getting restrictive, we don't really know where that's all going to go. Now, I will say that a number of luminaries, as soon as we started having restrictions of exporting equipment from that coalition to China, you had a lot of folks saying this is China's Sputnik moment.
Yeah.
Meaning, okay,
kick it into overdrive.
They got to go into overdrive.
Right.
And China spent a tremendous amount of capital trying to build a wafer fabrication or wafer foundry and even memory industry. They've now got to build a capital equipment industry.
Right.
And this is a country with tremendous scientific and engineering resources behind it. They're going to have to match. Now, the question is, how long is that going to take?
Right. I mean, and so, there's a lot of dependencies on, Japan, South Korea, Netherlands, obviously, ASML, then United States as well, other countries. who's the fragile partner in this coalition, right? There's a little bit of game theory going on. Every country would be, better served, in the short term at least, by selling a bunch of equipment, expertise, components to China. But who's likely to defect?
So 3 years ago, I would have said nobody. Mm-hmm. And the reason I would have said that is the geopolitical game board was pretty clear.
Yeah.
Right now, I think it's pretty murky. And I don't want to prognosticate on anything that's going on. But I think you mentioned Japan, South Korea, Taiwan. We've had unilateral trade deals between the U.S. and those three countries that resulted in an agreement about, okay, how is technology investing going to be done? And it goes well beyond technology that we're discussing here today. And these are economic relationships in the $500+ billion range between each of those countries and the U.S. and a commitment to each other. I think those are going to be pretty resilient. Where I worry about is NATO. Does NATO have a future? And with
evolving live.
It is evolving live, and the conversations between Denmark and the U.S. are
fraught.
They're pretty scary. And so if I look at facts and not prognostication, what the Dutch government did with Nexperia and taking control of a company,
and then what China did in response,
so that would tell me that the Dutch government is ready to act along the agreement that they have between the U.S. and the Netherlands. Does that sustain in a world where NATO doesn't exist anymore? I don't know.
Yeah.
But I think that the most recent activity that the Netherlands officials came through with, I would say, is very much in line with the coalition thinking that has been going on for some time. And just for maybe some of your listeners that don't know, why is the Netherlands important? It's important because of their ability to produce leading edge semiconductor lithography equipment, and that is from a company called ASML, and they are I would say a monopoly supplier, a one-of-one supplier of extreme ultraviolet lithography equipment. No one else in the world can make that.
Yeah.
At least yet.
Right.
And so they're important. If you want to design the next generation GPU or the next generation, anything that's going to consume tokens in a data center,
right,
it's going to be made with the ASML lithography equipment.
Right. And everyone else is, very far behind. Right. There's no fast follow here. Despite China trying. There's been a lot of reporting that former ASML employees and have been recruited and working for SMIC and other Chinese fabs, and the U.S. institutionally supplies a lot of the intel backing for these export restrictions to our allies. But it only works if it works much better if the allies are willing partners in this enforcement mechanism. They have a lot of on the ground knowledge, and obviously they have their own export control regimes and can work best. But it also, if you go down another layer, the actual firms, it also helps if they're willing. And so you have say like ASML or high bandwidth memory providers, Japan, South Korea. How much are those companies, internally, right? The leadership level, are they enthusiastic about this? Do they understand, or are they just like, you're costing me another $1 billion, right? I want no part of this. I'm only part of this to the extent that the stick is there.
So all these executives are citizens of a country, but they're also responsible for the well-being of their employees, the well-being and returns to their shareholders. Yeah. And so I don't think they really see this as a dilemma. They need to do what is in the best interest of their shareholders primarily. And I do think everybody looks at this and says, and I really don't like these restrictions. I would say that is more important for a company that has services and software connected to their product as opposed to a commodity component supplier. And I don't want to call HBM, high bandwidth memory, a commodity component. Yeah. But it's a component. There's not a lot of software that goes on top of that.
Right.
So I would say that hurts the HBM and the DRAM suppliers.
Yeah.
If you're selling GPUs with a software stack on top of it, or you're selling lithography equipment that has attached metrology and measurement and services, it gets much harder to say, man, I'm not only losing a sale,
Yeah.
But I'm losing a developer community. I'm losing a bunch of maintenance techs that are trained on that equipment. That gets tough because a lot of the returns to those businesses don't come from the chip sale or the equipment sale. It comes from the ecosystem you build around that, and that's why you have clusters like the Hsinchu Science Park or Gihang in Korea or Suwon in Korea or Shenzhen, because ecosystem in electronics manufacturing and semiconductor manufacturing is like the golden rule.
Right.
You put things in the same place so you can build a talent ecosystem around them, and it's self-reinforcing.
I mean, agglomeration effects are supercharged inside the industry. And so how much of a problem is, and how do you crack down on this? Is it you throw people in jail? And so how much of a problem is workers say, they just left, right? Take ASML, right? They've been like servicing Chinese, copycat ASML EUV machines, and I'm sure that's in South Korea's publicly put some people in jail and sort of caught some people doing similar things in China as well. But is that like the major leakage node of say process knowledge and the rest of that, or is it something else? And is the response you just put a lot of people in jail till the message gets across?
I'll come back to putting people in jail. And there's a lot of public knowledge out there of specific cases of IP leakage given an employee taken secrets either on a flash drive or in paper documents from one place to another. And I would say that kind of corporate espionage has been going on for a long time. And people get caught, and governments are still willing to prosecute that. And you can go out and look at some of the case law that's out there, and you see it. Now, I like to think, and this is kind of a little bit of a ridiculous rule of thumb that I learned when I was in Taiwan. But in Taiwan, for every cockroach you can see, there's 10 you can't see.
Yes.
And so I think there's a lot more of that going on than people realize, and because there's a lot going on that gets caught. Now that's, I would say, almost Edward Snowden level, sneaking secrets out in the Rubik's Cube kind of thing, where I don't think people have an appreciation, and I'm not tying this to any specific country, but cyber threats, we don't have an appreciation for that. Most people understand cyber threats as denial of service attacks, and that could be locking up a machine, locking up 30,000 machines like happened to Maersk, and some of the other companies got hit with ransomware attacks.
Yep.
What you can't see is IP theft.
Yeah.
And IP theft happens all the time. And where does it go? Attribution in cyber is extremely hard. You can almost never find out who the attacker was. Now, the good news is most of the stuff that gets stolen is encrypted. And so you get this big encrypted file, and maybe that's the lens design for an EUV scanner, or maybe it's the light source design for an EUV scanner, or whatever it happens to be, or even the bill of materials for an EUV scanner and how you put it together.
Yeah.
If it's encrypted, no one can use it because RSA encryption is pretty awesome. Along comes quantum computing.
Yeah.
Once we get at something with a couple of million qubits,
Store now, decrypt later.
that's right. I think that's anybody's guess. When do we see something that can crack, cutting edge RSA encryption? When that happens, I think the walls come down, and you're going to see a very quick acceleration of anybody that wants to create capital equipment of any kind. Semiconductor designs of any kind, and how to ramp capacity and how to ramp yield in a semiconductor fab. These are all more or less trade secrets, patented something.
So how do we treat this? Does the intelligence communities of the various countries get involved and say, if you are working on leading edge chips or in that supply chain, we are going to vet you just like if you're working on the F-35, where there is a security background check and there's training associated with that, and and some other things that you sort of have to give up for the privilege of working on this program. Maybe some like travel and reporting requirements. Is that is that what sort of has to happen? But it's not the F-35. The vast majority of these chips go into an Amazon data center that people are using to answer to do chatbot stuff, right? So
it's a great question. I've got two thoughts on it. First off, despite the profit levels that you're seeing from the semiconductor vendors today, they are not set up for that level of restriction. Nobody. I mean, honestly, there are a couple of ITAR compliant semiconductor manufacturing facilities in the U.S. That can do confidential projects or classified projects.
Right.
Those are set up to run but classified projects, but almost every fab in the world is not set up for that.
Yeah.
And those companies don't know how to run a classified environment. They don't know how to set up a SCIF. They don't know how to do any kind of work like that. And so I think that you need a built for purpose manufacturing ecosystem to be able to do that. That doesn't exist. That doesn't exist today. And we talked about it a little bit. And the Wall Street Journal had a really interesting article about something called the secure enclave that they really couldn't go into. Mm-hmm. So people are thinking about that, but the industry at large has not grown up in an environment like that.
But they could be forced to, right?
Could be forced to.
This isn't like something that is, we know how to do this, right? We have, secured, defense ecosystem, supply chains, and obviously very, very, very far from perfect if you read the news, but a heck of a lot better than nothing, right?
I agree with that. So, I would hate to see the semiconductor industry get into the world of the $600 toilet seat, which was like when I was growing up, that was one of the big, Senate testimonials about why our defense industrial base is a little bit crooked. Mm-hmm. But jokes aside, the industry, the management teams of the industry aren't ready for that. It would be a huge leap. And again, that's not a problem you solve in a year. That's a problem you probably solve it over a decade, because you are going to need to change the way you do fixed capacity. You're going to need to change the platforms that everybody's on. The platforms meaning the R&D environments and the cloud service providers and whether or not they're secure. And so, but what really I think underpins this is, where does it end? Okay, you put leading edge logic into there. Well, what about memory? Yeah. And then if you put memory in there, what about like advanced biologic manufacturing? And if you put that in there, well, what about advanced optics? Right. And do you put printed circuit boards and servers in there, or do you just put the really high end components in there? And I think if you get into a world where critical industry is now under a classified umbrella and really subject to scrutiny from some regulator, I think you wind up blowing up the cost base of the industry. And we talked a little bit earlier about valuations. Yeah. I think if there's one way you want to really hurt the valuations of the industry, it's let's put them under government control. Right. I'm not sure regulatory intervention is really what we want. And again, I come back to regulatory intervention is always welcome in this industry to support growth of it. Right. But when we start getting restrictive, we really have to be cognizant of the second and third order effects it's going to have. Okay, so put you made national security advisor. You're advising the national security advisor. Like, what very important industry, mega profits. We want to encourage this in the United States. We don't want to put headwinds on our companies, balanced with there's 10 cockroaches for everyone that you see, which means that there's a lot of cockroaches spilling secrets to China and Chinese firms. What's the balance there? I personally don't think you do nothing, right? Maybe it is a separate set of critical industry trade secret laws, which are like fairly draconian, and there's a bigger stick there without imposing a huge burden on the company. But I don't know. What is it? So I think the world's pretty set up for the cockroach thieving, right? For the folks walking out the door with the SD card and the Rubik's Cube. Mm-hmm. And physical security, we all understand that. You can tighten up physical security. It's not that expensive. We all know how to do it, and our investigative elements are pretty good at catching that kind of stuff. And maybe you tighten that up a little bit. I think if I was going to make one move, regardless of what role I'm in, I would say I want NIST or some other entity coming up with, what does quantum readiness mean from an IT protection perspective? Yeah. And how do I make sure that IT-intensive industries, whether it's self-regulated or government-regulated, how do I certify and know that these companies have encryption that's ready for the quantum phenomenon? So you mandate quantum-resistant encryption then? I think that's one way to go. And I think you're now mandating something that's probably 3 or 4 years away. You give companies the ability to plan for it. You come up with some standards and understand how these things are actually going to be, how you're going to judge compliance. Yeah. And we're already doing that in some cases online with ID. What does a digital identity look like? And this has put standards out on how to do that. And so I think that's something that I'm sure some brilliant person is working on it. Hopefully. But that's something I think, again, for protecting IP, we need to be ready for that discontinuity. And nobody knows when that discontinuity is going to come, so we better start working on it pretty soon. Yeah, I think it's scary. I mean, there's, I know that the federal government is definitely moving towards that. There's various FIPS standards, obviously, that are incorporating quantum resistance and
where do you draw the bounds on that though, right? Like how deep do you go? 6 supply chains deep is it that at that point it becomes like a universal mandate, right? Everyone shall adopt quantum resistant technology. Everyone shall do these fairly intensive security reviews. Like, where do you stop?
It's a great question. I even think you've seen probably a couple of years ago. The supply chain was the issue that most companies had, which was cyber attacks of a third tier supplier was getting secrets about a tier one supplier's issues, and so where does it end? Yeah, I don't know. I come back to how are you going to judge compliance on this?
Yeah,
and industries are pretty smart. If you go to an industry. A couple of industry leaders and say, "Hey, let's get ready for quantum. Quantum resistance important." I think you'd see a pretty rational set of actions coming out of each industry that's trying to be protective, and collective action is possible in these cases. So I would say as long as there's a good push and there's consistency, I think it'll work itself out.
Okay, I'm glad, right? Because I was less hopeful before talking to you there. All right, so shifting gears a little bit, we talked about, you mentioned the CHIPS Act earlier. All the incentives were structured around getting money to invest in the United States to build a semiconductor industry again here, right, after it withered away. And that's been like relatively successful, I think, at capitalizing, degree of private investment. But national security, dollars invested is not like the national security concern. It is, do we have the output, right, of chips and downstream things. And so to do a very early CHIPS Act retrospective, what's the right metric to judge by? Are we looking for, is it, progress towards self-sufficiency? Is it, we're building rebuilding the economic engine here? Have we successfully, coerced other countries to bring us the process knowledge? What's the success metric in the next couple of years for chips? From a national security perspective.
Great question. So I would say the metric that everyone wants you to see is percentage of leading edge logic capacity built onshore in the United States.
Right.
And the target for that, as announced by executives of TSMC, as announced by the Trump administration, is somewhere between 30 and 40%. That's the goal, and of course, that's a goal that's going to be it's going to be a moving target. But that's about what the U.S. would need in order to be self-sufficient for the U.S.'s needs.
Yeah.
Now, I will be the first to tell you that metric is necessary but not sufficient to guaranteed self-sufficiency of electronic supply. And so we again, there are so many metrics out there that you could use, but you really need global commerce to continue functioning in order to keep things running. So let me come back to the CHIPS Act. What's going to be success for the CHIPS Act over the next, let's call it 2 or 3 years? I would love to see 3 things happen. And I think this is all going to be kind of flow through from the investment tax credit part of the CHIPS Act.
Yeah.
Number one, I would love to see more memory production onshore in the U.S. Very little of that is being built. And if you look at the constraint to high-performance compute today, everybody talks about GPUs.
Right. It's shifted away from the fabs.
It's high bandwidth memory.
Yeah.
And it's advanced packaging capacity. And I really want to see self-sufficiency on those 2 dimensions as well. And if you just look at leading edge logic wafers, it again, necessary but not sufficient. We need to eliminate those 2 bottlenecks. And for the next 2 or 3 years, those are going to be the bottlenecks to advanced compute. So we've got to see movement on those 2. The second category I would talk about is talent. And I think I won't say we've overlooked talent, but we're still probably about 300,000 engineers and technicians short of what we need. And we don't have them.
Does that just mean we blanket offer everyone who works for TSMC a green card and say, hey, welcome to America? Or
I mean, I went, I kind of publicly said this a couple of years back, but I said, hey, and I hate saying this in a world because immigration is so politicized right now.
Yeah.
But like, we need to be stapling green cards to STEM diplomas. I mean, we have to get people who come over here and utilize the U.S. base of educational institutions to make the workforce better. And you can go look at, I mean, just Arizona is case number one.
Yeah.
Not only do we not have enough engineers, we didn't have enough cement layers and electricians and plumbers to go and build these things. And even securing the sites was difficult when it's being produced. So I think I really I'd want to see some kind of metric around workforce efficiency, and us beginning to close that gap. Because as I said, the fixed capital stock is a 15-year problem. Like, talent is also a 15-year problem, and we need to be able to see some progress against that. And watching fabs get built in Arizona is great, and that's a great way to visualize the capital stock. But like, okay,
who's working in the fab?
Who's working in the fab,
and where are they being taken from? Like, there's relatively full employment right now. Every single STEM graduate is more or less employed, and so you're taking them from somewhere to put in TSMC, and that somewhere is suffering.
And the other big pipeline so STEM diplomas is one, but folks leaving the military is another one where that's another really good onboarding program.
Yeah.
We probably need 10 more things like that where, we're pulling people out of, again, 4 years ago, I would have said this was happening, but now I'm not sure. But like internal combustion engine factories, you kind of thought that we were at the tail end of seeing internal combustion engines being produced. Now, probably not anymore.
Right,
but like, technicians that know how to build an engine, they know how to maintain an etcher or a plasma etcher or an atomic layer deposition machine. Yeah, you can get into that.
Growing homegrown talent is a 15-year process, right? And probably more, because there's some guy in Taiwan or South Korea who's been doing this for 30 years or 40 years. And, presumably they've, acquired some bit of knowledge in the past, in that time period between 15 and, 40 years. And, from an immigration perspective, is very fast to draw those people in. If we made the political choice to do so, I don't think that the Taiwanese, South Korean governments would appreciate it if we offered effectively all their engineers more money, because American salaries are higher, and created replica industrial clusters in the United States, in Arizona, or Ohio, or wherever. But is that viable? Is that is that the near-term solution? Because we might not have 15 years, quite frankly. I think there's a very good chance we don't have 15 years.
I think that is the solution. And whether I don't think that's a federal program. I think that's probably something like an economic development bureau of a state or even a city. And you can go on to into a gossiping employee site like Fishbowl and go look at what everybody's talking about with employees of some of the companies of countries you just talked about, where there are employees coming over here that have 30 years of experience and are supposed to train hundreds of Americans in how to do that kind of work. We don't help ourselves in the way that we set these things up. And so if I was going to, we've got some clusters that are forming now in the U.S. and there's some in Texas, there's some in Arizona, there's some in New York, there's some in Ohio. We need to make it pleasurable for our Taiwanese and Japanese and South Korean colleagues to come over and set that up. And, that's going to take some foresight. And I don't think that is on the companies themselves to figure out how to do. These companies they know how to build fabs, or they know how to build capital equipment for semiconductors. They know how to maintain it. I don't want to have them design a neighborhood and a school system to be able to take care of some expats that are going to come over and train the U.S. So there's a lot more foresight that needs to go into that to make it work and be successful. The automotive industry did that for years.
Yeah,
right. You got all the Japanese auto companies came over to the U.S. and built factories, and that's a playbook that everybody knows. We just need to be able to have the political will to replicate it.
Yeah, and perhaps the automotive industry, perfect analogy to perhaps us being less aligned on that sort of strategy politically is right. What happened to the I think it was the LG plant, right? Hundreds of South Korean workers got rounded up and arrested and treated very poorly after that as well. It became a diplomatic issue, but there's actually no real backtracking from that that I saw, at least. And there's probably political trade-offs with other political objectives that the current administration has. And I don't think that's being prioritized.
Yeah, and I would say, was that intent or mistake? I don't know.
But regardless,
if you listen to the New York Times interview that came out in kind of, I think, first week of January, with the president, it sounded to me like that was an accident.
Right.
I don't know. As somebody who spent a lot of time living in Seoul, and somebody who knows a lot of Korean executives, I could say that was pretty damaging.
Yeah.
And
I mean, I think I read the same article where like I definitely believe this was not like a White House on down sort of thing, but it was a deliberate choice not to bend over backwards to make this right, and make it up to the firms and the people, and and really apologize in a meaningful way.
Yeah.
And that is a strike against anyone who wants to import knowledge and build the next battery factory in the United States.
Agree with that. And so as we've been discussing here, I think the two things that, just from a future perspective, that I think we've kind of hit on is, one is what's the future of NATO? Mm-hmm. And the second one is what's the future of immigration policy in the U.S. And both of these things are super important to this industry, and so we need to be ready to react to those. By the way, you asked me the question about the CHIPS Act metrics, and I gave you one on scarce capacity of HBMs and advanced packaging capacity. We talked about talent. The third one, and this honestly has not much to do with the CHIPS Act, but we still need to look at it, is power availability.
Yeah.
So this is, if you went over and interviewed somebody in Taiwan and said, what's the barrier to growth of the semiconductor industry in Taiwan? They would say two things. They would say power and water. Mm-hmm. It's also true in the U.S. Grid availability is scarce. Data centers are growing like crazy. Those consume a tremendous amount of electricity. And water reclamation, water availability, power availability, and grid margin are extremely important.
Yeah.
And it's probably not that common of knowledge, but the rate at which a company that is funding data center construction and the rate at which a public utility make business decisions is like the tortoise and the hare. And it's probably a terrible example, but public utilities like to make decisions on adding to the grid and controlling the grid in decades.
Yeah. And
companies that make data centers, I was talking with a couple of executives last night at an event, and they're adding a data center a week.
Yeah.
Right. And that doesn't mean they can build a data center in a week, but it means they have 150 data center projects, one of which is completing every week.
Right.
Public utilities don't add grid capacity in the same vein.
Yeah, and the water is effectively a non-issue. I mean, it's a closed loop, but the electricity, I mean, that's become it's become a political lightning rod where people see that, somewhat marginal for now increase in their electricity price. But I mean, there's no doubt in my mind that any hyperscaler can outbid me heating my home for electricity if it really came down to it. And so I think that's going to be like an increasing political issue. But we, the United States, don't add grid capacity fast. China, on the other hand, is building the commensurate number of power plants, and I think they could probably kick it up another degree or two if they actually wanted to. And so, at some point, it becomes, say their chips, whatever we sell them, the H200s, homegrown ones are, say they only get 1/3 as many flops per watt. Well, if they have 3 times the electricity generation in 5-10 years. Okay, well, now they're producing the same amount, right? It's not as capital efficient, yada yada. But I could see that being the limiting factor being gigawatts devoted to it, and that's like I mean, am I wrong to see that as a possible win path for them?
I'm not sure grid margin and gigawatts help you win, but it certainly will keep you from winning if you don't have it.
Yeah.
So it will become a constraint. And I do a little bit of a shout out to Dan Wong here. The whole concept of the U.S. is run by lawyers and China is run by engineers. I think that is going to be an issue for. I don't want to say an issue, but it's going to be something that the 30-year-olds of the world right now are going to wrestle with for the next 20 or 25 years.
Yeah.
And the nimbleness of the U.S. economy And some of the articles that came out talking about TSMC's travails in being able to build in the greater Phoenix area just go and put some real meat on the bone there, because they had to document like 18,000 procedures.
Yeah.
And I thought that was I found it to be an interesting number, but I also found it to be a very sad number. We have built fabs in this country. We don't build many of them, but when you want to go and build them and you have to reinvent the playbook,
it's painful.
It's painful.
Yeah, and it doesn't help. All right, so going back to the CHIPS Act real quick, we sort of went on a tangent there. From a national security perspective, how much does the leading edge matter, right? Should we instead be focused on, we can have these secure enclaves, there's lagging edge things that can go into defense applications, or testing, packaging. Is there something else that we should be considering instead of the ability, from a national security perspective, instead of the ability to produce the leading edge, instead of the ability to drive investment, which great, but is not national security?
Sure. I mean, if you go and talk to any military commander just about what is critical to mission today, compute is critical to mission today.
Yeah.
Compute is central to digital communications. Compute is central to any kind of coordinated operation that's going to involve communications and timing and everything else. And so leading edge absolutely is a critical to mission capability. Defense industrial base needs to have their hands on, or I would say military units need to have their hands on in order to make it work. Now, of course, it doesn't stop there. I mean, we need leading sensing capability. That almost has nothing to, you have to process what comes in from the sensors.
Yeah.
But sensors are inherently analog devices, and you do that, you manufacture those in a very different way. And you've seen, just CMOS image sensors, which is what's in the back of your smartphone. You've seen tremendous progress on black levels and noise sensitivity in those, and you just think about what a military application or a satellite imagery device needs. There's an entire roadmap of improvement that needs to be delivered on those. We can go into quantum. That's another technology that is going to be very important to the military. It's going to be very important to any industry that needs to do physics and chemistry simulation or material simulation. And material science and physics and chemistry are obviously very, very important to anybody that's producing kinetic systems of any kind. Quantum's going to be important. So where are you making qubits?
Yeah.
And who's making those?
And 6 layers downstream.
Yep. And yeah, there's a lot. I mean, I was shocked. We did a little analysis of the quantum supply chain, and there's a very interesting component that goes into any quantum system that requires cold temperatures called a dilution refrigeration machine.
Okay.
A dilution refrigerator, and there's like one company in the world that can make dilution refrigerators at any scale. And that, I think, if I'm right, that company happens to be in Finland. And so it goes like to the, if you go and probe down deeply on any of these highly technical industries that are developing, you wind up with single points of failure, and they're all over the world. And so it's like, it again goes to, hey, if we're going to start restricting global commerce and get into some kind of escalatory regime with an adversary, man, the second order effects, third order effects of that could really go the wrong way.
And like in the meantime, when we're in this export restriction regime, right? Which I think if quantum hits, right, in the next any time it hits, right, when we finally actually figure it out in a meaningful way, it's probably going to be like an AI level transformation of society, right? And I think AI is going to be the most important invention since electricity, quite frankly, if not more. And I mean, quantum's going to have, something similar probably, and it's going to change the way we think about the world. And our, wrapping this back to like Finland, right? Our allies, I mean, like militarily, they're probably not going to contribute that much realistically in a high-end fight. But I'm really glad that the Dutch are our allies, because without them, China would probably have some really advanced EUV machines right now.
I don't disagree.
Okay, so CHIPS Act, right? Do these? So we're producing our own, right? We've decided to allow H200s in China. Is this the right move? Are we selling plutonium to the Soviets here?
I would say. I would say no. And why do I say that? China, and this isn't just China, but it's anyone with trade restrictions, right? And there's a lot of companies that the U.S. has placed trade restrictions on. These countries have lots of smart people. And if you take lots of smart people, particularly engineers and scientists, and you put them on a problem, they're going to find a way to solve it. It might take them a little bit longer, but they're going to find a way to solve it. And everybody heralds the DeepSeek moment that happened in 2025 as, hey, look at the ingenuity that China is able to show. And there's lots of subtle arguments in there about, okay, well, how, was that really off the cost per token roadmap, or was it really off actually, it's kind of what you would have expect somebody to be able to do, but they were able to do more with less and came through with something that was pretty compelling. And I think you're going to continue to see that. Now, the question is, I'm going to get away from the national security implications of this for a second, but I'm just going to go to the commercial implications of it. Right now, you can arguably say if you're writing code that has to be, that is going to do deep learning or a transformer-based model, which is what all the LLMs are based off of. If you're coding on that, you are a CUDA developer.
Which is NVIDIA's proprietary.
That's NVIDIA's stack that they've been investing in for 15 years. Do we want the world running on CUDA? Or do we want a fractured world where some folks develop on CUDA and some folks develop on, let's say, a Huawei stack, and some folks develop on something else? If you look at the world, if you look at the history of microprocessors and the history of the computing era, it's always best to have developers all working in one thing because you get returns to scale. The more scale of developers you have, the bigger the open source community gets, and the faster you get innovation. And so I think the business leaders of the world would say, is this a right move, exporting H200s to China? Yeah, because you want all these brilliant Chinese developers writing to the CUDA stack. Now, is that in the best interest of China? I don't know. Is that in the best interest of national security?
Well, I think they don't think so. I mean, they've restricted the ability. They're not stupid.
So, but again, is that a political response, or is that a fundamental logically driven response? I don't know, right? I haven't gotten to go do any interviews in China recently, so
not eager to share their their strategy there. Okay, well, was there anything that what did we not cover?
I'm glad we got to talk a little bit about power because I think that usually gets swept under the radar. I'm glad we got to talk a little bit about the kind of some of the more mainstream technologies and what is required for sensing and what's required for quantum and what's required for even just guidance systems. You don't need 2 nanometer technology to be able to do that. You need 130 nanometer technology to do that. Well, again, most of that stuff's produced in Taiwan too. So that's why Taiwan's so important. It's not important just for leading edge logic. It's important for pretty much everything. Right? TSMC is a 90% plus supplier of leading edge logic. They're also like a 55% supplier of almost everything else. So they're material. The one thing we didn't discuss, and I don't think this is really well appreciated, and we're just starting to scratch the surface of this. And it's a little bit of, why is the tunnel through the mountains and why is the railroad pitch width in Utah what it is? And it's because of the Morton Thiokol rockets that were like the boosters for the space shuttle had to get from the Morton Thiokol plant in Park City out to Orlando or Cape Canaveral, and that's why the holes in the mountains are that big. But if you look at a leading edge semiconductor manufacturing process, from the time you stick the wafer, the prime wafer, which is bare, it doesn't have any circuits on it, it's just a polished silicon, monocrystalline silicon surface, until that comes out and you can cut it up and make it into useful things, that's about 180 days of manufacturing at like nanometer precision. Yeah. Right? So that's a long time. When product cycles today, like for years, used to have something, everybody talked about Moore's Law, was about every year and a half you had a new product generation. Yeah. Now it's every year. And when your lead times
NVIDIA's coming out less than a year now.
And so I just say we're reaching a point where the manufacturing time to make something and the rate of introduction, and you only learn when you see what you made. And so like the cycle of learning on 180-day cycle time, if you're introducing products every 9 to 12 months, you don't have a lot of time to learn before the next thing's coming out. And so we're going to need to rethink that paradigm a little bit. Now, interestingly enough, there's a company in Japan that has decided to make this their kind of their discontinuity, and I haven't seen that manufacturing line produce something at any scale yet, but they're claiming they've got about a 30-day cycle time because they redesigned the way their equipment work. Most pieces of semiconductor capital equipment take in what is called a front opening unified pot, or FOUP, and that holds 25 wafers in it.
Okay.
And that's why I kind of made the space shuttle booster analogy. And the reason why it was 25, I think it's just because a long time ago Intel said, well, 25,
dependency.
right? And everybody kind of agreed on the standard. We're going to use 25 wafers as kind of the atomic unit of wafer fabrication. Well, they're going with single wafer. Everything is a single wafer processing machine, and so you're not waiting on the other 24 wafers to get done before you can move the pod. Now it's just like the wafer goes by itself. And that has disadvantages from a scale manufacturing perspective, but you're going to have so much faster cycles of learning with a 30-day cycle time. And that I don't think is appreciated.
Yeah.
And I think we haven't seen that even begin to ripple through the industry yet. But we're going to have to see it, because you can't have 9-month product introduction cycles and a 6-month manufacturing time. It just doesn't work. You're going to have a hiccup in there somewhere.
Yeah. Oh, cool.
Hiccups hurt.
So thank you for coming on. One last thing I want to ask, I ask people for an object lesson. So one personal, one professional recommendation that you have, something unique.
Okay, so I'll give you one non-unique, but I got to give a shout out to Chris Miller. Chris Miller is a professor at Tufts. I read very few books where I said, "God damn, I should have written that." But it was Chris Miller wrote a book called Chip War. And it's been out on the market for years.
Yeah.
But it's great. And if you really want to spend 4 or 5 hours and get a really detailed understanding of the semiconductor industry, Chris is an economic historian. You get an economic historian's view on the semiconductor industry, and it's really good. And it gets almost to, leading edge issues in 2022. And Chris is going to come out with another book sometime soon, I'm sure. But I would say if you're curious about semiconductors, that's a great place to start. The second thing I'll say, and this goes to, AI adoption is really fueling the industry growth right now. Everybody knows that. I had dinner with Reid Hoffman a few months ago, and we were talking about, Reid talks to institutions, not just companies, but academic institutions, government institutions, what have you. And I said, Reid, what's going to drive broad adoption of AI? And Reid uses the word super agency, which is kind of a fancy term that I'm not even sure what super agency means.
Yeah.
But Reid's thought was, if you're a member of a team of any kind, take an hour a week with that team and have a dialogue on what is one thing you tried using AI last week and how did it work. And the inherent positivity bias in most people will want to talk about a success story, not a failure. And so, don't go recommend individual tools, but just go around and talk about, hey, I found this to be an interesting. Some people talk about how they plan vacations. Some people talk about how they built an agent to do some of the work that they do. But just getting in the habit of self-reinforcing learning, particularly in hybrid workforces where some people are in the office and some people aren't, we need to make sure that adoption's happening, because you could imagine that if we have, non-uniform adoption of AI, the digital divide is going to get even wider than it is today, and we don't want to have that happen. So I would say that's just an ask for anybody that works in any kind of a team environment. Take an hour and do that once a week, and I think there's returns to making that happen.
No, I think that's an excellent recommendation. I work in the AI industry broadly, and me and everyone I know, right, use AI extensively, but it is, a little bit jarring for me when I sort of step out of that bubble and talk to people who, are not immersed in this world. And there are many people who don't believe in AI, right? Like I don't use it. I don't want to use it. It's not useful. I've tried many things in the past and they don't work. And I would just encourage anyone listening, right, to realize that this is different, right? This, I promise you that this is different. And I think I'm preaching to the choir here, but
and on the flip side, the other interesting thing is I have a 17-year-old son, and he's deathly afraid of it because he gets, his teachers at school often say, you can't use AI for this, and he'll write an essay, and I'm like, hey, let's upload this to Claude 4.5 and have it give you feedback as if it's a high school English teacher.
Yeah,
I was like, Dad, I can't do that. I can't do that. I'm like, no. This is
no.
This is like you're writing this in Google Docs. This is another tool, just like Google Docs. I mean,
right.
Yeah, sure, you could whip out a pen and paper and handwrite it, but like, come on, let's work in modern times here. And these are tools that just accelerate learning. They don't really, of course, they can take away from an educational experience, but we're moved up the stack.
I mean, I remember when I was in school, my teacher saying, go to the library, really, don't use Google, right? The internet, anyone can put anything out there. And it's like, obviously that is no longer sound advice. And everybody is going to be using AI in a extremely integrated way into their lives. And if your school is not encouraging that, you are not setting kids up to succeed, right? Like there's something to be said for like developing the thought processes, I think, like definitely, but this is also a skill.
Yeah. Let me just put one cautionary note out there before we leave this topic. So, one of my favorite memories back from my Navy days was we were all learning navigation, both land navigation and at sea and littoral navigation, all at night. Mm-hmm. And so this was right around the time where you were getting, this is like 1993, okay? So it's a long time ago. This was right around the time we were all getting handheld GPSs. And these things were about the size of a shoebox, mm-hmm. So a little cumbersome and had a little antenna on it. It would take about 20 minutes to sync up with a couple of satellites. Yeah. But you would get an 8 or 10 digit grid coordinate off of it, which can spot you on the Earth pretty much anywhere within 100 meters of where you are. And to have one of those, you had to pass the map and compass and triangulation from buoys or whatever you're using to triangulate while you're at sea. You had to learn how to actually navigate so you understood it. But then you got your GPS. And once you get the skill of learning how to navigate and fix your position on the planet, mm-hmm. It's not like you're going to forget that. It's kind of like riding a bike. Yeah. But then, we all use GPS from then on out. And I guarantee if you go talk to any Special Forces unit or any Army Infantry unit, they're all using GPS. But do they know how to land navigate? Of course they know how to land navigate. So, get the skills that you need to have so you have something to fall back on when all the technology breaks down. But don't be afraid of the technology. It's a competitive advantage. Yeah. So you got to learn to use it. You asked for one personal of these two. Mm-hmm. So I'll leave you with a couple. Okay. And it's I'm going to say I learned a term a little while ago called the friendship recession. And it's a little bit of a COVID hangover issue that we all kind of have. Most of us who are knowledge workers, we do some remote work. We don't collaborate as much as we did in person anymore. Mm-hmm. And then on top of that, we're all aging at the rate of 1 second per second. And so it just naturally, you kind of distance yourselves from the people that were in your life. And most folks, the friendship recession just means, most of us used to have 17 or 18 pretty good friends, and now we maybe have 10. Yeah. And so it's like, how do you cure the friendship recession? And so I've done two things, and I probably need to do a few more. But I just decided about a year ago, I'm going to take the different aspects of my personal history, mm-hmm. And I'm gonna create a really nice dinner out of those with a collection of people. So I brought together a couple of professors, a couple of military people, a couple of politicians, a couple of business people, and got them around the table and had one person talk about a topic and just lead a discussion. And man, like, it was great. And we all still kind of catch up with each other. And I'm about to do version 2.0 of that next month. But just having the initiative and pulling together disparate parts of people that and getting them in a room to talk to each other, I think it's a great idea. It takes a little effort to plan, but it just really helps you continue to build a network over time in an era where networks are shrinking, not growing, and networks are, even in the age of AI, networks are super important. The second one, and this is a bit more personal, one of the guys that I invited to that dinner happens to be the CEO of Hasbro. Mm-hmm. And during the cocktail hour ahead of time, I overheard him talking about his Dungeons and Dragons campaign that he runs. And I didn't even know that Hasbro owned Wizards, which owns D&D. Yeah. And all of a sudden he's like, hey, you want to come playing my campaign. And I'm like, I haven't played D&D since I was 16, right? So it's almost 40 years ago that I haven't played this game. But man, I've played now in his campaign 3 times, and it's delightful. It's a great way to meet people. Cool. It's a great way to get out of your shell. And if you ever played D&D when you're a kid, you get back to your roots and you get to explore adulthood in a new and interesting way. And I think the world of it. And that's actually something I'm going to be prioritizing this year. Where if I need to fly to the East Coast to make a D&D campaign, goddamn it, I'm going to do it.
I like it. That's awesome. Yeah. Well, thank you so much for coming, Bill. I really appreciate it. Appreciate your time and expertise. I learned stuff, and so thank you.
Really enjoyed the discussion.
Thanks.
Thank you.
All right. My name is Chase Sultan. Thank you very much for listening or watching. If you would not mind, please share with a friend, rate, review. It's the lifeblood of new podcasts. And until next time, see you later.
Cheers.